Okay guys, today we're going to look at how to graph inverses. In our last lesson we talked about how to find the inverse given an equation. One of the first things we need to note about inverses is that they are always symmetrical to the line y equals x, and that the points of a graph and its inverse simply switch. So here in this example we have a quadratic and its inverse, a square root function. And so when I say that they switch, or you could also use the word flip-flop, we're going to take the y column, or the x column, and put it in our y column. So we would have 0, 1, 2, 3, and 4 to go in our y column from the x, and then your y column becomes your new x column, so 3, 0, -1, 0, and 3. Alright, and so not only do the points flip-flop, so do the domain and range. So I have the domain and range already listed for the quadratic. We ought to know that it's always all real numbers for the domain, and so that will become the range of our inverse. Alright, and then the range of our original equation becomes the domain of our inverse. And if you notice, a lot of times there is confusion. We're going from y to x, and so make sure that you change that to an x for the domain. Alright, so now let's take a look at graphing these. Let's get our nice x and y axis here. And like I said, you have the line y equals x for the line of symmetry. I would suggest always go ahead and draw on that first. It is a very helpful visual. It's an imaginary line. If you were to graph these in your calculator, you would not see that line there, but you should see the symmetry when you start graphing the points. So we'll do this one in green. We have 0, 3. Then we have 1, 0. And we have 2, -1. And then we have 3, 0. And 4, 3. So this is the graph of our original equation, our quadratic. And now we have the graph of our inverse. Now some people would feel comfortable graphing this, and some people may not. So if you don't feel comfortable, you can just use those points to flip-flop. So we have 3, 0. We have 0, 1. -1, 2. 0, 3. And 3, 4. And so there's the positive square root function. There's the negative square root function. And so you should see it kind of makes a heart, but there is that symmetry. This point here is good. Anytime they intersect, it should be on that line. You can see that it wasn't 100% precise. It looks like they intersect a little bit off the line, but it should be intersecting anytime on the line of symmetry. And again, this is the line y equals x. Okay, so now let's take a look at another example. All right, in these examples, we're going to also find the inverse, then find the domain and range for both, and then we're going to graph both the original and its inverse. Okay, so here we have a square root function, and if you recall from the last video, we talked about switching x and y first. And so if we rewrote this with a y instead of f of x, and then you switched x and y. Now we want to solve for y, and if you remember, we talked about the list of steps that we could use. So if I knew what y was, what's the first thing we would do? We would subtract 3, and then next thing would be the square root, and then the last step would be to add 2. So for our inverse, and this one here is f of x, for our inverse, we're going to do the opposite steps, if you recall. So step 1 would be subtract 2. Step 2 would be to square instead of square rooting. And then step 3 would be to add 3. So our inverse, okay, if we subtract 2 from both sides first, we get x minus 2 equals the square root of y minus 3. And then square both sides. Then we get x minus 2 squared equals y minus 3. And then we add 3 to both sides. We get y equals x minus 2 squared plus 3. All right, so we have x minus 2 squared plus 3. Now, before we graph, I do want to go through and find some points for our table. This is a special case, and I think it'll become more apparent once we find this information for the square root function. Let's say on our, and you can do this in your calculator by plugging it in Y1 and then hitting second graph to look at a table. I know that we need to start at 3 because 3 minus 3 is 0. And then if you add 2, because the square root of 0 is 0 plus 2 is 2. And then if we put in a 4, 4 minus 3 is 1, square root of 1 is 1, plus 2 is 3. Now, if I'm using numbers I know the square root of, I would want a difference under my square root of 0, 1, and the next perfect square is 4. So I would jump to 7 because 7 minus 3 is 4. And the square root of 4 is 2 plus 2 is 4. All right, so based on that information, if we flip-flop the x and y columns, so your x column, 3, 4, 7 goes into y, and your y column, 2, 3, 4 goes in the x column. Now the domain of a square root function, and we have to think about this because we have a square root, we can't square root negative numbers. And so if you think about the number I started with, that's what gives us 0. And so our domain is x has to be greater than or equal to 3. Because we can square root 0, we can't square root negatives. And anything less than 3 would give us a negative under the square root. Its range, in this case, is going to go with our y value when x is its lowest. And so that would be 2. And it's going to be getting bigger, so we see that y is greater than or equal to 2. And so typically the domain of a quadratic is all real numbers, like in our last example. But if we follow this idea of points flip-flopping and domain and range flip-flopping, then you would see that your domain for your inverse is going to be x's. Sorry, let's do it the same colors we were using before. Is that x would be greater than or equal to 2 because it switches with the range. So this is going here. And then your new range is y is greater than or equal to 3. And so what this gives us is called a restricted domain. And so when you would write this problem, we would say x is greater than or equal to 2 as part of the domain here on this. Okay? Sometimes the way you'll see this is you'll see it written as x minus 2 squared plus 3. And then they just give you this little piece here and says where x is greater than or equal to 2. So you're only graphing a parabola using x values 2 and greater. And so what that looks like, let's make that black. Okay, so what that looks like when we graph it, if we start off at 3 and get 2, so here at 3 and we get a 2, and then we put a 4 in and we got a 3, and then we put a 7 in and we got a 4. Okay, and so our graph looks like this. Now, its inverse, and you know what? I forgot to draw our line of symmetry. And so our line of symmetry, y equals x, so it's 1, 1, 2, 2, 3, 3, etc. Okay, looks like that. So we can already kind of eyeball and tell that, we can already tell that our graph should be somewhere over here, right? Okay, so one thing I also want to point out is visually, if you can see that you're about a half a diagonal away, and so your next point would be there. Okay, remember we said that was 2, 3 is one of our points. And then we had 3, 4. So 3, 4 right here. Again, also about a half a diagonal away. And then this one here is about 1.5 diagonals away, which is where we get our 4, 7. Okay, and so, sorry, wrong dot. 4, 7. And so you can see the symmetry, and you can see that this is only half a parabola. And that is where the idea of the restricted domain comes into play. Okay, so pay attention when you're going from a square root function to a quadratic, you're going to need the restricted domain. Kind of like when you're going from a square root function, a quadratic to a square root function, you're going to have to remember to put that plus or minus in front, because you're going to need the positive and negative versions of that square root for the inverse. Okay. All right, so we got one more example. Okay. So this one here is a bit more simplistic. You have a linear equation, and we do need to find its inverse. So we can go ahead and switch that x and y. And I don't know that we need to write out the list here. I think we ought to be able to subtract 4. We ought to be able to solve this without writing out a list. And then we divide by 2. And so we say y equals x minus 4 over 2. Or some of you might feel more comfortable writing this as 1/2 x minus 2. But it's not really super important, because we ought to be able to graph this based off of our original equation here. And we don't even actually need this equation. We want to be able to find it, but we don't actually need it to graph it. So if we started, I think this would be easier to start our graph, just because of the simplicity in graphing linear equations. Okay, so if you remember y equals mx plus b, this is our b, and this is our mx, and so that's the slope. So the b is our y-intercept. We want to start at 4, and then we want to rise 2 and run 1, and we could go the opposite direction, and that would get us here and here, etc. So if we connect those dots, get ourselves a line that looks like this. Our line of symmetry, again, is y equals x. It's always y equals x. I probably should have drawn that line first. Do better than me, guys. So just based on this table here, or these points, we can create a table pretty easily. So you start off at 0, 4, and then you have -1, 2, and you have -2, 0, and we had 1, 6. Let me squeeze that in there, 1, 6 above. So when we change this, when we flip-flop it, let's go with blue, you would have 6, 4, 2, 0 in your x. So your y goes to your x, and then your x's go to your y. So 1, 0, -1, -2. And so if we go to graph that, you have 6, 1, which would be right here. and then you're going to have 4, 0, and then we would have 2, -1, and 0, -2. And so you'd see that it hits -2 and had a slope of 1/2. And so there's our graph of our inverse. Now with linear equations, the domain and range here is all real numbers. If you guys remember that little symbol, or we can write all real numbers. Throw a number sign in there instead. And that would flip-flop to here, to all real numbers. There's not a whole lot of visual flip-flopping here because they're the same for both. All real numbers. And then the domain of your inverse is all real numbers. Okay guys, I hope this video helped. If you have any questions, please feel free to email your teacher and ask further questions. Okay guys, I hope you found that lesson helpful. Here's some extra practice that you can do. I have put the answers down below so that you can check yourself before we move forward. This would be a good time to hit the pause button because, as I said, the answers are down below.